Okay, these are the notes for 8-1. 8-1 I'm splitting up into 2 days. It kind of has a lot of stuff in one section. So today we're just going to focus on the Pythagorean theorem. The Pythagorean theorem you've learned about before. I know you did in Algebra 1. It only works in a right triangle, so you have to be really careful. It's not just any triangle. You need to make sure it has a right angle. It says the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. A squared plus B squared equals C squared. The important part here, the A and the B are always the legs, and the C is always the hypotenuse. It's actually most important that you identify that part first to make sure you're setting it up correctly. A Pythagorean theorem triple is whole numbers that make the Pythagorean theorem true. For example, a 3, 4, 5, 3 squared plus 4 squared equals 5 squared. That's an example of a Pythagorean triple, where the numbers aren't decimals or radicals or anything. They're whole numbers that make the Pythagorean theorem true. And in the next slide, we're going to do a proof. I took it from 422, number 48. It started with this picture. And maybe that picture looks familiar to you. We had done it before with our previous chapter. So I have a right triangle with an altitude drawn to the hypotenuse. So what I'm going to use there are some of the similarity ratios we saw before. So A is the leg of the big right triangle, of the big one, this big one right here. So I know A is the geometric mean between the part that touches it and the whole, so between Q and C. So that's how I set up this proportion. A is the geometric mean written twice between Q and C. And then I cross multiply to get A squared equals QC. B is a leg of the large right triangle. So B is the geometric mean between the whole hypotenuse and the part that it touches, R. So I set that's how I got this proportion, and then I cross multiplied and got B squared equals RC. Now, if I add A squared and B squared together, that's equal to adding QC and RC together. It's addition property of equality. So I got to here. Then I factored out the C because I had a common factor of C. I factored that out. And then Q plus R. If you look up here, what do Q and R make up? They make up C. So C times Q plus R is the same as C times C, which is C squared. And look at that. You've just proven the Pythagorean theorem. Now, there's hundreds of ways the Pythagorean theorem can be proven. I took you through what I think is a simpler one. President Garfield did prove it back when he was in, I don't know if he was in office or not when he actually did it. It's been proven through different continents, different countries, and it has even been around since Babylonians. They knew about the Pythagorean theorem then. All right, so over here, all these white squares here are me hiding answers, so don't try those. In this first triangle, you're finding x, and then you're finding y. You're going to find x over here, and I kind of drew the picture for you here. So what I'd really like you to do is to push pause and try this on your own. And then push pause, work through these problems, then come back and check your answers. I am going to be looking for these notes, so please make sure you are taking these notes. Okay, so before you start, the very first thing is identify your C side. So here's my right angle. I go across, so this is my C squared. All right, so push pause now and work through those. All right. So in this one, my C squared was x, so I had 2 squared plus 3 squared equals x squared. 4 plus 9 equals x squared. And then square root both sides, I get x equals the square root of 13. In this triangle, 6 was the C squared. See, that's the one across from the 90-degree angle. So it's not always the variable, it's not always y squared or x squared here. You have to kind of see which number is there. So I had y squared plus 4 squared equals 6 squared. I squared the numbers. I subtracted 16 from both sides, and then I square rooted both sides. The square root of 20 simplifies to 2 root 5. In this one, again, 4 is the C squared. That was my first part. So x squared plus x squared equals 4 squared. If I have an x squared and I get another x squared, now I have 2 x squareds. So that's what that is. I divided both sides by 2 to get to here. And then when you simplify the square root of 8, you get 2 root 2. And over here again, the x that I'm talking about is the diagonal. I knew the legs is 4 squared and 8 squared. So I simplified those, I square rooted both sides, and when you simplify the square root of 80, you get 4 root 5. All right, over here I have some problems. Again, the big white boxes are me hiding answers. These are a little more complicated, but again, look and see where the right triangles are and what you can work out. So you can work in your groups, kind of leave this up and try and figure them out. So please push pause, try on your own, and then come back and see if you got them right or if you need to tweak what you did a little bit. So push pause now. All right. In this problem, it's an isosceles triangle. And I know that because these are both 5. So an isosceles triangle, the altitude bisects this. So I knew it was split into 4 and 4. Now, when I looked at just this right triangle over here, 5 is the side across from the right angle, so that's my c squared. So I did x squared plus 4 squared equals 5 squared. Subtracted 16 from both sides, square rooted both sides. All right, over here, I have an isosceles trapezoid. Well, this is a rectangle in here, so if this is 11, that means this is 11. And if that's 11, 21 minus 11 means I have 10 to split between these. And I can prove these triangles congruent. So I know the 10 is split equally. So I know this little piece here is 5 and this little piece here is 5. So once I had those, I knew x squared plus 5 squared equals 13 squared. Again, I knew that 13 was the c because that's across from the right angle. And then I solved that and I got 12. So in the next one, you actually had to draw something in. You might have figured out where since I drew that in. You had to draw an auxiliary line. So I drew a line here to break it up into a rectangle and a right triangle. And since this is a rectangle and this is 5, I know this side is 5. Since the whole side is 11, if this side is 5, then this leg is 6. So this part is 6. And a rectangle, opposite sides are congruent. If this is 8, then this is 8. So 8 squared, because I got that, plus 6 squared equals x squared. And I solved that, and I got 10. Okay, so again, you're looking for the right angle. With Pythagorean theorem, it's very important to figure out which is the c side and make sure that goes in the right place. Okay, please check today's announcement to see what your homework is, and you may work on that at this time.